The last major topic we're going to talk about in the trigonometry chapter in this course is the idea of trigonometric identities. And this is an idea that's very different than what we've worked with previously, but it combines a lot of the things that we've learned already at this point, actually with a whole lot of algebra and a lot of algebraic manipulation. So we've done a lot of graphing, we've done a lot of transformations. Of course, earlier in this unit, we did a lot of work with right triangles and developing all these different definitions. It's very much going to go off in a different direction. Much more algebraic direction, a little bit more related to things that might feel a little bit more like equation solving. So let me set this up first of all. What exactly is the concept of a trig identity in the first place? Well, to give you an illustration, I wanted to take a look here at the cosine function. If you remember, the cosine function starts out at a maximum value of 1, hits a minimum value of -1. It crosses the axis at 90 degrees, which is the same thing as pi over 2 radians, hits a minimum at pi radians, or 180 degrees, then hits the axis again at 3 pi over 2 or 270, and it finishes one cycle at 2 pi radians, or 360 degrees if you're working in degrees. Anyway, you can see that it actually crosses the axis back at negative pi over 2, or negative 90 degrees. And as a result, it's almost the exact same shape as the sine function, except it's been shifted. And you can think of it as having been shifted back pi over 2 units. If you remember, the sine function passes through the origin, okay? So I can take this cosine function and I can shift it forward 90 degrees, or actually I can shift it forward, I guess pi over 2 radians is really what I would be doing here, since I'm working in radians in my labeling, okay? But anyway, 90 pi over 2, either way. It's gonna shift that whole thing forward, okay? And if it shifts this forward, what you're gonna end up with is a graph that does this. If you notice, that is the sine function, okay? So cosine of x minus pi over 2, or cosine of x minus 90, if you're working with degrees, is literally the exact same function as the sine function. Okay? So here's the challenge. The whole idea of an identity is the idea that two different things can be the same thing. Okay? Cosine of x minus pi over 2 is the same thing as sine of x, okay? You guys have seen this before with fractions, for example. 2/4 is the same thing as 1/2. 5/10 is the same thing as 1/2. You've seen it with radicals. Radical 20 and 2 radical 5 are the same thing. Lots of different ways that you can write those radicals that are equivalent. One of the challenges of working with trig expressions is going to be that they can be written lots of different ways, but it is actually the same statement. And so the question is, how can we change these statements and write them different ways? And also, can we take really complicated statements and possibly break them down, simplify them to statements that are a little bit more straightforward, okay? So that's what we're going to be working with, really algebraic manipulations of trigonometric statements to write them into other forms that are equivalent, or in some cases to simplify them down to things that maybe aren't as complicated, or in some cases to show that two statements that don't look like they're the same really are the same thing, okay? That's going to be the concept that we're going to be working with over the course of this unit, okay? So I want to start you out with just one basic relationship, and then I'll take you a look at some others. The first one I want to look at is one of the most well-known of the trig identities. Oh, by the way, some trig identities that we really need to know. Remember that sine of an angle, well, we know what sine of an angle is. Let me start with the inverse trig functions. Remember that cosecant of an angle. Cosecant is the reciprocal of the sine function, so it's 1 over sine of theta. Or I could say that sine of theta is equal to 1 over the cosecant of theta. They're reciprocals of each other. It goes both ways, okay? Secant of theta is the reciprocal of the cosine function, so make sure you know that relationship. And finally, the cotangent function is the same thing as the reciprocal of the tangent function, okay? Those are trig identities. They're equal. So anywhere I see a cosecant, if I want to put a 1 over sine in place of it, I can. Anywhere I see this, I can put that. Anywhere I see that, I can replace it with that other statement. Or again, the reverse. Okay, so sine is going to be the reciprocal of cosecant, if you have some reason to do it that way. Cosine is going to be the reciprocal of the secant function, and of course tangent is going to be the reciprocal of the cotangent function. So anywhere you see one of those statements, you're allowed to replace it with another. Okay, now let's look at a pretty basic trig identity for starters. What I'd like to try to simplify is the statement tangent, just kidding. I'd like to simplify the statement sine of theta divided by the cosine of theta. Okay? And there are different ways that you can do this. I'm going to set up a right triangle here, and I'm going to see what I can find. So if I make a right triangle here, let's make this angle theta. I'm going to label this side with an A, just a variable value, this side with a B. And to keep the number of variables down as low as possible, I can use the Pythagorean theorem to get a labeling for this side. That would be the square root of a squared plus b squared, if you use the Pythagorean theorem. So that's going to be my labeling for the third side. Okay? So what I'm going to do is, in this fraction, I'm going to try to substitute in equivalents from this statement over here and see what I can make happen here. So let's start out with the sine of theta. Sine is opposite over hypotenuse, right? So the sine here is going to be A over this. So I'm going to have side A over radical A squared plus B squared, okay? That's the sine of theta, okay? In place of cosine of theta, I'm going to fill in everything in my triangle as well. Cosine is adjacent over hypotenuse. So that would be B over radical A squared plus B squared. Okay? You may look at that fraction and may say, oh my gosh, there are 4 parts there. That's ridiculous. What's going on with that? Okay? But here's really the key. Remember, when you divide by a fraction, it's the same thing as multiplying by the reciprocal. Okay? So that's the same thing as A over radical A squared plus B squared. And I'm going to multiply by the reciprocal of this. Okay? And take a look at what happens here. Okay? If I multiply these two things together, I'm going to have a radical A squared plus B squared on the top and the bottom. I can divide that out of the top and the bottom, and I'm going to be left with just A over B. Okay? Now the question here is, what's the significance of that? Well, I want you to look back at that and see what A over B is. Notice, A is the side that's opposite the angle. B is the leg that's adjacent to the angle. Opposite over adjacent is the tangent function, okay? For any angle measure, if you take the sine of that angle and you divide by the cosine of the exact same angle, that is the equivalent of just taking the tangent of that angle. And so this is our first trig identity, okay? Anytime you've got a sine over a cosine, you can write it as a tangent. Anytime you have a tangent, you can replace it with a sine over a cosine, okay? Now, these two things are equal, so I can write that statement in lots of different ways, and I can get lots of additional facts out of it. For example, if two things are equal, their reciprocals are equal. So I could say that cosine of theta divided by the sine of that same angle is the reciprocal of this. That would be cotangent of theta, okay? That would be a rule that would also be true. I could take this statement here and I'm going to rewrite it here real quickly. Okay, this is being divided by cosine of theta. I could multiply this side by cosine, and I could multiply this side by cosine, and these would cancel, and I could find out that the sine of an angle is the same thing as the cosine of that same angle times the tangent of that same angle, okay? That would be an equivalent statement, okay? I can divide both sides by tangent here. Okay, and I could show that the cosine of an angle is equal to the sine of the angle divided by the tangent of the angle. Now, do I memorize all those things? No. Okay, but the point here is that you can manipulate these around. What should you memorize? This right here. that the sine of an angle divided by the cosine of an angle is the tangent of the angle. And you should be able to get any of those other relationships from that. Now, what are we going to do with that? There's a lot to come. But that's the starting basis for where we're headed.